Once again, at the very top part of your next page in the concept book, we're putting chapter 2, box it up. We're talking about rational number operations. And today, let's talk about simplifying fractions. When we say rational numbers, we're talking about what kinds of numbers? Rational is ratios, which are, what do they look like? Fractions. So I had a class who graduated last year, and they came up with a little song. You can go watch it on Math 7. I think on my website I have the 7th grade little video on rational is fractional. This is what they came up with. They said, rational is fractional. Divide. Do you see this is like a division bar, right? Can you want to sing it with me? Ready? Yeah. Go. Rational is fractional. Divide. So go online, look for their video. It's kind of cute. They're all in high school now. So, simplifying fractions. Mark just said it correctly. A fraction is a ratio, right? It shows division. It's one number divided by another, typically. Sometimes we have algebraic variables in there too. So as a rule, we could show a fraction as A over B. Good, that's a rule. That's good thinking, A over B. Let's talk about what is in a fraction, because sometimes people get confused by the names of these terms. So up at the top, the A is known as the numerator. How do you remember that? I have a way, but how do you remember it, Matthew? Over, oh, he's giving us the other word, denominator. So for those of you who might struggle with which is which, often people think of north as up, like the North Pole is up there, right? So and numerator is like the north thing, the up thing, and down is the denominator, under, down, denominator, under. So that's how some people remember it. Mark said that you're dividing by the denominator, so that's another way of thinking about it, okay? Today we're going to put some fractions in simplest form. So here I have a fraction, and don't say it, but jot down this fraction 2/4. And what does a person need to do to put that into simplest form? Okay, Cooper?
You divide 2 by each side.
Okay, so he wants to divide the top and the bottom both by 2. And when you do that, you get
4.5.
And so, good. And is 1/2 in simplest form?
Yes.
How do you know it is, Cooper?
When the top number is prime.
Okay, well, what is it possible to have two numbers that are not prime? Like, for instance, let me think. How about 8 over 15? I mean, those numbers are not prime numbers, so tell me how to reduce it.
It's already.
Okay, so you could have a fraction in simplest form and neither number is a prime. So how do you know a number is? We need another reason. Jensen.
Because you can't divide them.
So what number, in our original fraction, Cooper told us what number could go into both of those?
2.
They both had a factor of 2. So we could get rid of that factor of 2, bless you. This one, 8 and 15, they have factors. I mean, 8 has factors of 4 and 2, right? And 8 as well, and 1. 15 has factors of 15 and 1 and 5 and 3. So why is it in simplest form when they do have factors in them? There you go. They don't have anything in common. So the factors of 8, which are 8, 1, 4, and 2, well, actually, I shouldn't include 1, huh? 8, 4, and 2, none of those can be found in 15. And 15, 5, and 3 cannot be found in 8. But the one that they both have in common is actually what? 1. So when you have 1 in common, you're called relatively prime. Everybody say that. Relatively prime. So compared to each other, the only factor they have in common is 1. And that's what this says. Their greatest common factor is 1. Okay, so equivalent fractions. How do I know that a fraction is equivalent to another? Like in the last example, we had 1/2 and we had 2/4. I mean, if I just gave you those two fractions and said, are those two fractions equivalent? How could you prove that they are? Skylar.
By making the right one in simplest form.
She says, change the right one to simplest form. Why didn't you say change the left one to simplest form?
Because that's already in simplest form.
So the left one's already in simplest form. So she's saying put them both into simplest form. Listening now? Put them both into simplest form. And if the simplest form matches up, then we know they are equivalent. It's exactly the way you do it. Good job, Skylar. So equivalent fractions have the same exact simplest form. So sometimes we could blow a smaller fraction up to prove the same thing. So I like to say blow up. It's kind of fun that we blow things up in math, right? This example, 1/2 and 2/4, instead of changing the 2/4 into its simplest form, could we blow up the 1/2?
Yes.
What factor would we multiply the numerator and denominator by over here to get to 2/4, everyone? Everyone? 2, right? If we multiplied the top and bottom by 2, we end up with 2/4, which equals 2/4. So, most often people like to go to simplest form to compare fractions. You can also blow things up. Absolutely free to use whatever method works for you. Emma mentioned another really fun way to check whether fractions, are equivalent. So looking back here at our little one that we know is equivalent. She said you could just go and multiply, you could just kind of cross multiply. And 2 times 2 is 4 and 1 times 4 is 4. So yes, these were equivalent. Isn't that cool? It's another little trick to determining whether we have equivalent. That also helps when seeing which fraction is greater. It's a method that can help us there too. Okay, and let's add that in. Luca said you could also change the fractions into decimal form and check it out too. And that's true too. And sometimes when we're comparing big lists of numbers, people like that. They like to change a fraction to its decimal equivalent. So these two fractions, use whichever method you like. Are they equivalent fractions? Thumbs up when you know. Thumbs up when you know. And I can't see everybody yet.
I can't see the second.
And then I want to hear how you found it. So are they equivalent, Claire?
Yeah.
And how did you find it? She says yes. How did you find it?
Well, because if you make a 1530 smaller, then
Oh, she shrank to, okay, you divided by 5, top and bottom? And you got the other one.
yeah.
Okay, that's one way to do it. How else did you do it, Michaela?
I divided it into simplest form, so like 15/30 divided by
Okay, she
15.
made this 1/2 and this 1/2. Who else did it that way? You put them both in simplest form. And did anybody do it differently? And how did you do it, Luca?
My decimal way,
Okay.
I did 3 divided by 6 and 15 divided by 30s.
Okay,
And I got 0.5 on both. So
0.5 on both. There it is again. And Alex?
I got an over cross multiply.
And you did 90 equals 90, right? And there's another way, the way that I did it, nobody has mentioned yet. Miles?
You guys do 3 times 5.
That's what I did. 3 times 5 gave you that one, and 6 times 5 gave you that one. So there's so many, that's the blowing up way, really, right? There's so many ways to find this, okay? And we have 2a over 4b. Now this is a step up for fractions because we see variable expressions. Audrey, Sophia, stop. How can I put this fraction in simplest form? What could I do there, Kyle? Is there anything you can do to change the a over b? You don't know what a and b are, so there's really nothing you can do there. But how about the 2 over the 4?
Yeah.
What could you do, Kyle? Do they have anything in common, Dr. Weiss?
Simplify it into 1/2.
You said simplify it to 1/2. So is it okay if we call this 1a over 2b's?
No.
Why not? Mark?
Yeah.
Why not?
Because 1 times A does not equal the same thing as 2 times A, and 2 times B does not equal the same thing as 4 times B.
Actually, what we're just simply doing is dividing the top and the bottom both by 2. And we get 1A over 2B, so it is equivalent. What does 2 over 4 equal as a decimal?
2 over 4 equals 0.5.
And what does 1 over 2 equal as a decimal?
0.5. But
Same. So these are equivalent. They are equivalent.
but it's like,
Okay, the other thing we could do with that same fraction is blow it up if we wanted to. What if we multiplied the top and the bottom of this fraction by 2? What would we get? What is 2A times 2? 4A, and 4B times 2. Good, so we could end up with that fraction. So when you have a fraction that involves variables, they still might be simplifiable, right? Or blow upable. You could blow them up, you could shrink them down. You just worry about the numbers that are there. And later we'll talk about how we can simplify variables too. This is a really interesting question. Can you find a number between two fractions? So just put it down and see what you can come up with. So sometimes we don't want to change fractions to simpler form because it's easier to work with them when they're not simple, when they're blown up. So this is a pretty straightforward question. I think I could ask a 5th grader this. What's between 3/6 and 5/6? And they would say?
4/6.
4/6. So we might say 4/6, but could you actually simplify 4/6?
Yeah.
And it is?
2/3.
Good, you're dividing top and bottom by 2, and you got 2/3. So we could actually say 2/3 is between 3/6 and 5/6, right? That's all you have to do. But what happens when you face this then? Hopefully I've given you enough hint. What fraction is between 1/2 and 1/3? They feel so tightly together, don't they? So what strategy might you use to find a fraction in between those two? Sophia?
1 over 2.5.
Oh, that is really ingenious. She said 1 over 2.5. Who agrees? Thumbs up if you agree. The only problem with that fraction is you have a fraction in your fraction again. 2.5 is 2.5, right? 2.5? And so we don't usually consider that to be simplified when you have a fraction in your fraction. So I like your thinking though. And I know how you could get that number changed, but I don't know if you know that yet. So who has another idea? Matthew?
1/6.
Yes.
And how did you get that? He says 1/6.
1/2 and 2/6.
So he blew this up. He blew up 1/2 to be called 3/6. And I guess you're going to blow up the other one too, are you? And he blew this one up to be 2/6. Well, okay, in between 2/6 and 3/6, is there a 1/6 in between those two? So I don't know if you blew them up maybe enough. Could we blow them up some more?
Yes.
Let's blow them up by another, what, another factor of 2?
I got 5/12.
Okay, so Kyle says blow them up so the denominator is 12. So 6/12, and what is the, only if you have the answer you may say it. What is it, Sika? 4/12. Now, can you find something between 4/12 and 6/12?
Yes.
5/12. So there's our answer, 5/12. Okay, so sometimes when asked a question about a fraction lying between two small fractions, we may need to do a big blow up of the fractions, give them a common denominator, and then we find something in between them. Okay, I really love Sophia's idea of 2.5. She knows that 2.5 is between 2 and 3. 1 over 2.5, she said, right? And so you know what you could actually do with that? Who knows how to blow this fraction up so that there's no decimal there at the bottom? Sophia, do you know? Oh.
How many 2 over 5?
Okay, she can multiply the top and bottom by 2, she says, and get 2 over 5. Excellent. Beautiful. Isn't that interesting? The other thing you could do, I often move decimals by just multiplying by guess what number? What moves a decimal in our place value system? By 10, right? And so if you multiply top and bottom by 10 here, you get each of those decimals moved over to 10 25ths. And doesn't that equal 2 fifths?
Yes.
2? So very interesting, good strategy. Okay, so speaking of variables in fractions, let's simplify algebraic expressions. And the number one rule when you're faced with a bunch of variables in your fractions is simplify first. Always, always, always simplify the expression first. So here we have a variable expression, an algebraic expression, and we are given the numbers that we could substitute. But before we substitute, we can go try to simplify first. This is a fraction that has common factors in the numerator and denominator. Who sees a factor that's in the numerator and denominator? And what is it, Mouse? Okay, he sees 2. So he wants to divide 4 and 6, both of them, by 2. And what do you get? So 2 over 3. So just for the number part, he divides them both by 2. Okay, how about any other common factors? You see it? Michaela?
X and X.
X over X. What is any number over itself?
0.
1, right? Except for, what's our exceptional number?
0.
0. And if you have a 0 down there, it's called
Undefined.
undefined. Good. So look at those X's. We know they're not 0. Look at, we were told what it is. Right? They're going to be multiplicative inverses. They go away. And we're left just with Y. Okay, so there's our simplified algebraic expression. And now we're ready to just substitute the 3. So 2 times 3 over 3. Wow, what can we do now? Do you see what we can do, Sophia?
So you multiply, it's 2 times 3 is 6. It'd be 6 over 3,
Which is?
which is 2.
Which is 2. Or look at another multiplicative inverse, and we have 2. So either way, you have 2. Try these now and come back and check when you're done. And there you can walk through it to see what we did.